this is word break, lead code problem 139. So you are given a string, S, and also a dictionary of strings, which is an array of strings. So you are to return true if this string input can be segmented into a space-separated sequence of one or more dictionary words. So in example 1, the string you're given is lead code, and in your word dictionary, there's an array of strings. First one is lead, second one is code. And so you're going to return true because you can segment the input string to be words in the word dictionary, specifically lead and code. In the second example, you are also returning true because you can segment this whole word into apple, pen, apple. So you can reuse the dictionary word, but this string can be broken up into words that are in the word dictionary. So for this input string, cats and dog, you are returning false because if you segment cats and or dog, so because and or sand or dog and sand are overlapping, you can't evenly segment this string. So we could take a look at what that looks like. So this is what the input looks like in wordbreak. You have your S, which equals this string lead code, and then you have this word dictionary, which has lead in it and code. So what we can do to solve this is look through the substrings and see if we can make it through. So when you're making a substring, you can chop up the string with the index. So each letter can be at an index. This is a 1. You start off with 0, 1, 2, 3, 4, 5, 6, 7. So there's 8 letters and 8 indexes starting at 0. So when you do a substring, so let's start off with our first substring. You tell the substring, where do you want to chop up this string? So you want to start with 1 and you want to end off with another index. So if I start off with 0, 0, that's actually going to give me nothing, because when you're doing a substring, it leaves off the letter that is your last one, so it'll chop it off in front. So for instance, if I have a substring of 0, 0, it will give me nothing because it's the same index, not just because it's 0. If I do a substring of 0, 1, that's going to be equal to L. If I do a substring from 0 to the 2 index, that's going to give me a substring equal to LE. So when you're using the substring, this second index is exclusive. So it's not including the second index, it's leaving it out. Okay. So as I'm searching through this string, I can just start off at 0, check if it's in the dictionary, check if LE is in the dictionary, check if LEE is in the dictionary, and I found one that's in the dictionary. I found a substring that is in the dictionary. So what does that substring look like? The substring is going to be equal to, we're going to start at 0 and then it's going to end at 4. So substring 0, 4 is going to be equal to LEET. So we're going to use a Q to keep track of what indexes to search from, and I'm going to use a hash set to make sure that we're not searching from the same spot again, just in case some of the letters are repetitive. So let me just clean this up here. So I have my Q and my hash set. I'm going to start searching my substring from 0, and I'm going to add that 0 to my hash set too, so I don't start searching from there again. So my current, as I'm going through the Q, my current is going to be equal to 0 right now. I took it off the Q and I made it my current. So as I'm searching through, when I get to index 4, I'm going to find a complete word. When I find a complete word, I'm going to add that to the queue and I'm going to continue searching. So I found lead, I didn't find any other words here. So I'm going to end it and I'm going to search for the next item on the queue, which is 4. So I'm going to take 4 off of the queue and I'm going to make it my current index. So my current index is going to be 4. I'm going to add 4 to my hash set and say these are the indexes I already searched from. So from 4 to 5 to 6 to 7, and actually this is going to be to 8, so it's going to be to the entire length, because my substring is going to be for 8, and that's going to give me this string called code. So when I get there, I'm going to find that is in the dictionary. I'm also going to say I have reached the length of this string, which is 8. So that means I'm going to return true. Okay, let's see what this looks like in code. So let's make a queue of type integer. I'm going to name it Q. And a hash set. And I'm going to call of a type integer. I'm just going to call it HS. So the Q and then the hash set. Okay, so we're going to start off adding, we're going to try to make our substrings. So we're going to add index 0. We're going to start off at index 0, checking all the substrings. So while the queue still has indexes left in it, while it's not empty, let's search. So let's get our current index, and that is going to be equal to what's first coming off the queue. If we can add this current index to the hash set, so this will also return a Boolean, and it'll also add that index to the hash set at the same time. So we don't even have to check if it contains, we'll just add it to there, and if that adding is successful, let's go from this current index to find substrings until the length of this string s. Okay, so for int I equals this current index, I is less than or equal to the string length, and again, that is because when we are doing our substring, it is exclusive. So if we want to get the substring from, say, C until the E, it has to be until the length, which is going to be 8. And then we're going to do I++. So we can say if the word dictionary, so since it's a list, we can just ask it if it contains this substring. So we want the substring current index and then up until I. So if it has this current index, we're going to add this index into the queue. But even before we add it into the queue, if I is equal to S length, so if we got all the way through the string, we can return true at this point. But if we're not at the end of the string yet, we're going to just add that I onto the queue. And if we get all the way through this and we never reach I, it's too many. Let me straighten this out here so we can figure out where I'm going to return. This is this, this is this. And this is, well, Q is empty. If we get all the way through this, we are going to just return false because we never reached that last index. Okay, let's try to run this. Okay, and that is that.